For me, it's not, it's available, but for anyone else, yes.
So I don't know if you already answered this one, but like for example, if that was negative x square root of 1 plus x squared, would that have any effect on?
No, no, we can even change it if you want.
I mean, like for example, at the end, what if the beginning was still x? What if the beginning was still the same with the negative x, but then at the bottom you got negative x and you had positive
Here?
Yeah, plus x squared.
You mean plus here?
Mm-hmm. Yeah.
That will not be possible.
Okay. Oh, okay.
Because when I multiply both sides by -1, I do not distribute inside the square root. I cannot do that. So that's a very good question. So let's say this. If I have 2 the square root of 1 plus x, and I want to multiply for whatever reason, let's say I multiply this by -1, these are 2 factors. I can only distribute to one of them.
I meant like what if the result happened to be negative x to the square root of 1 plus x squared? Would that still be?
No, they will not be the same.
Got it. Okay.
So if this one has minus here and this one, or plus, and this one has minus or vice versa, this expression will not equal this expression. So they have to be absolutely identical. Otherwise the function will not be symmetric. Either this way, the f of negative x with f of x, or this way, f of negative x with the opposite of f of x.
Okay.
If anything changes, or if anything, it's a very good question, if anything changes and if they're not identical, either f of x with f of negative x with f of x, or f of negative x with negative f of x, if they are not completely identical, if these two are not identical, this side and this side, or these two are not completely identical, the function is not symmetric. Yes, thank you. Okay, so our next step is to look at a problem. Do you think we need more examples with symmetry? Yes, very good. So here it is. If you'd like to pick one, I'll tell you where they are, and you can pick any problem you want. They are on page. It's a very good I'm sorry, I was still in 2.1. So if you have your book, or if you'd like to pick, they are on page 250 from 37 through 48. 37 through 48, page 250. If you don't want to choose, I will. 1, 2, 3. Okay, I'm choosing 39. So f of x equals x squared plus x. The same question. We're asked to determine whether the function is odd, even, or none of the above. In other words, is it symmetric? What do I need to determine? Very good. So f of negative x, what do I write? Very good. Awesome. Plus, let's write it with parentheses for now, although it's not going to be different. Negative x. Good. So then, negative x squared will be replaced by, very good. But plus with minus, yes, very good. So then I have again 3 questions. Does this equal identical function, which is, maybe it's easier to see, x squared plus x? Does this equal the negative f of x, which means I multiply both sides by -1, which is negative x squared minus x, or none of the above? Maybe this is easier to see. So, does this equal the original function? No, so this is crossed out. Does this equal the opposite of the function? No. What do we conclude? The function is not symmetric. When we get the chance to graph this function, we will not get any help from the symmetry. This function happens to be not symmetric. Not even, not odd. Good. Okay, so I would like to pick a problem now and go through a lot of questions with you. Any problem you would like from 49 through 52. On the same page, 250 to 51. It's kind of a long problem, but it's not a difficult problem. It's asking us all sorts of properties, identify all sorts of properties of the function, the domain and range, x-intercepts, y-intercept, max, min, symmetry, increasing, decreasing, everything. So please choose any problem you would like to see. If not, I will choose. Okay, I will choose 51. And here it is. I'm going to go copy the graph. Here's the graph. First question, does this represent the function?
Yes.
By the vertical line test, this is a function. Okay, now, domain. They want us to find the domain of this function. Do you all agree with negative infinity to 3? From the leftmost point till the rightmost point. Do we agree with the domain being negative infinity to 3? Yes? Is that a yes? Yes. Very good. Range. Can anyone give us the range of this function? So let's take a look. And when we determine the range, we cut it with horizontal lines. From the lowest y value till the largest y value. Perfect. Awesome. Any questions? Stop me if you have any questions. The zeros of the function. Remember what we said that the zeros were? The same thing with the... Very good. Indeed. The zeros of a function or the x-intercepts, same thing. Good. Can anyone identify in an ordered pair format the zeros or the zero of this function? Awesome. This is indeed one of the x-intercepts. And very good. 3, 0. This is the second one. It doesn't have to cross. If it's just touching, it's the same thing. It's an x-intercept. Agreed, everyone? Please. Okay, very good. The next question in line is f of 0. We're asked to find f of 0. What does f of 0 mean? Indeed, f of 0 is the y-intercept. Does this function cross the, or touch? Does it touch or does it cross the y-axis? Yes, and the point is? Awesome, thank you. Great job. 0, 3. Any questions? So here's the point. It's right here. 0, 3, that's the y-intercept or f of 0. Perfect. Next one. Intervals on which the function is increasing and intervals on which the function is decreasing. By the way, is this function constant everywhere, anywhere? No. So we want to find the intervals of increasing and decreasing. So from the x value of negative infinity till which value? Till 1. The function is always increasing from negative infinity to 1. Not from which value till which value, but the trend on the x-axis. Is that clear? No. Okay, let's go back. A few minutes ago, we said that between 5 and 10, the function is increasing. Between 15 and 20, the function is increasing. So that's all we are saying right now. that between negative infinity and 1, the function is always increasing. Is that okay?
Yes.
Perfect. So now the function is decreasing on 1, 3, all with parentheses. Very good. Values of x for which f of x is less than or equal to 0. So let's analyze this. Find x such that f of x is less than or equal to 0. This is the function. Function less than or equal to 0, or function under the negative means function is under the x axis. Negative function is when the function finds itself, or we find the function under the x-axis. Okay, both. So here it is. Look at this function and say, oh, this piece is under the x-axis. This other piece is above the x-axis. So in other words, if I pick an x value between negative infinity and negative 3, the function values will be what type of numbers? Negative. But if I pick a number between negative 3 and 3, the function values will be positive. That's all we're asked to determine. Find x such that the function is 0 or negative. So where is the function 0 or negative? It's 0 here, it's 0 here, and it's negative between negative infinity and negative 3. So the correct answer would be for x in the interval negative infinity to negative 3 closed, but also union one other point, one other value for which the function is 0, 3. So the function is 0 at 3 and is 0 at negative 3, but it's negative to the left-hand side of negative 3. Any questions? Any questions? Okay, next. Any relative max and the numbers at which they occur. I go back to the graph and I say, I trace the graph. It's increasing and it's increasing and it's increasing till this point, and then it starts decreasing. So obviously it has only one point of relative, but which type? There are two types. A max, very good. So here is the point that is a relative max. Very good. Where does the relative max happen? It happens when x is 1. It happens when x is 1. So I will say at x equals 1, f of x has a, one more time, has a relative max. Now what is the relative max? The max value is 4. Which ordered pair did we read from? 1, 4. Is that clear, everyone? Please ask any questions, anything. Is this okay? Okay, so let's look at what else they want. The value of x for which f of x is 4. So now they want find x such that f of x is 4. Let's analyze what is given in this question. What am I given so I know what I have to find? What is given? When I say to you, f of x is 4, what am I giving you? Am I giving you x or am I giving you y? Exactly, awesome. I'm giving you y. What does that mean? How do I graph y equals 4? It's a what type of line? It has altitude or position. If it is altitude, it's a horizontal line. If it's about position, it's a vertical line. Is it an altitude or a position? Position will be x equals. That's where the position is. It's an altitude. So here it is. I have to graph a horizontal line, which is y equals 4. It meets the graph in this point, and I have to read the corresponding y value. Forgive me. And I have to read the corresponding x value, which is 1. So then x is 1. When f of x is 4, x is 1. Is that clear? Final question. Is f of negative 1, is it positive or negative? We already know, but let's look at the graph again. F of negative 1. What is given in the question? Is it x that is given or is it y that is given? Very good. How much is x? Okay. What type of line is x equals negative 1? Does it give the altitude or the position? The position, which is a vertical line. So I will graph a vertical line, x equals negative 1. It meets the graph in a point, and I will read the y value. Yes, from my graph is 2.5. So f of negative 1 equals 2.5 from my graph. From the actual graph, f of negative 1 will be 2. So you can write from the graph, actual, it is 2. But from my graph is 2.5. So is it positive or negative? Positive. Which we knew, because the question from before, right here, see? Negative 1 is not between negative infinity and negative 3, where the function is negative. So it must be positive. Any questions about this problem? Yes. The graph? Yes. So I drew a vertical line at x equals negative 1. It crossed the graph of the function. Then I read the corresponding y value. When I'm given y, I draw a horizontal line. It meets the graph, and I read the corresponding x. When I'm given x, I draw a vertical line. It meets the graph, or it crosses the graph in a point, and I read the corresponding y value. So it depends on what I'm given. That's why I'm always reading the problem, and then I'm asking you what is given. So if I'm given x, I draw a vertical line. If I'm given y, I draw a horizontal line.
Okay, I get it. Thank you.
My pleasure. Any questions? Are we comfortable with reading from graphs, max, min, increasing, decreasing, and other like x and y intercepts? Yes? Do you think we need another example, or can we move on? Say it again. Can you spend some time with me after class so we can do one more? Okay, I will be more than happy. If there is only one student, I will spend time with her after class. If there are more answers yes, I will do another one right now. Yes? Yes? Okay, well, let's do another one then. Okay, so let's take a look. Here's a graph. I'm going to copy 49 on page 250, and here's the graph in 49. Perfect. So is this graph symmetric with respect to the origin or the y-axis? No. Function is not symmetric. By the way, is this a function?
Yes.
By the vertical line test, this is a function. We're asked to find the domain, range, x-intercept, y-intercept, and then we continue. Domain, please. Do you all agree that it goes from negative infinity to positive infinity with no gaps? Very good. Can anyone give us the range? Do we all agree with the range being -4 to positive infinity? Yes? From the lowest y value to the largest y value? Is that a yes? Good. Next question. X-intercepts. In ordered pair. One comma 0. Very good. 7 comma 0. Do we all agree with 1 comma 0 and 7 comma 0? Now the y-intercept. Do you all agree with 0, 4 as this point right here as the y-intercept? We agree? Yes? Okay, next question. Intervals on which f is increasing. So f increasing, f decreasing, and f constant. On. Let's start with constant. Not for the values of y, but the values of x. So from negative infinity to 0, perfect, the function is constant. Negative infinity to 0. Agreed? The functioning is increasing. So here's the function constant. Where is the function increasing?
4.
Very good. From 4 to infinity. From x equals 4 till infinity, the function is constantly increasing. Perfect. And the function is decreasing? Very good. Awesome. From 0 to 4. So constant, decreasing, increasing. Agreed? Very good. Next question. The number at which f has a relative min. F has a relative min at, I should say x first. Which x? Very good. And the y value now is -4. Which point did we read from? Comma. That's it. F of -3. They're asking us to find f of -3. What is given in the question? This is very important. If you say x, then I will draw a vertical line. If you say y, then I will draw a horizontal line. Is it x or is it y? X, which means I will have to draw a vertical line. X equals -3. It crosses the graph of the function, and I have to read the corresponding y value. 4. F of -3 is 4. And then you will give me the ordered pair that we read from. -3 comma 4. Very good. The values of x for which f of x is -2. So this time we're asked to find x such that f of x equals -2. I'm going to ask again the same question. Am I given x? If it's yes, it's a vertical line. If I'm given y, then if it's yes, it's a horizontal line. Very good. It is a horizontal line. I go to the graph. I draw a horizontal line, y equals -2. It crosses the graph of the function in 2 points. Again, we're not going to be able to read from my graph. And I will be able to read 2 x values. From the actual graph, those will be 2 and 6. So let's assume that this is 2 and this is 6. They're not on my graph. They're off. So f of x equals -2 means x equals 2 and x equals 6. So there are two ordered pairs, 2 comma -2 and 6 comma -2. And the last question is this function odd, even, or none of the above? Is it symmetric with respect to the y-axis? Is it symmetric with respect to the origin? No. So I will say the function is not symmetric. The function is not symmetric. The last item from this section 2.2 is what it's called. We're still talking about functions. We're still talking about properties and how we determine different things. It's called the difference quotient. What is it? Why do we need to determine it? So let's start by explaining what it is. The difference quotient. So let's take a look and look at the graph. Let's graph a function. And here's the graph I would like to pick. This is function f of x. And I am going to pick 2 points on this graph. One here and one here. I'm going to call this point A and I'm going to call this point B. And I am going to connect them with a line segment. Every point on the coordinate system has an x value. And a y value, which is f of x. I am going to say that this point is very close to point A. And you can say it doesn't appear to be. Let's say I zoomed in. So this is a short distance away, but in order to explain, I enlarged it. I zoomed in a lot. So this is small. We like to call it a distance h, lowercase h. Then what is this? If this is x and this is h, what is this? Of course. And now please tell me what is the y value of this point. Say it again. No. No. Indeed, thank you very much. That's how we started today. We had a function, and we determined f of x plus h. For this. For this, we determined that. Okay. Now I would like you to give me the slope of the line segment AB. By definition, the slope is rise over. Very good. Which means that by rise, we mean difference in y values over difference in x values. So can anyone give us the difference in y values? Meaning how high we went on the vertical scale, how high we went from A to B, and then how high we went, or I'm sorry, what is the distance, horizontal distance that we covered if we went from A to B. We covered the vertical distance and we covered the horizontal distance. What is the vertical distance that we covered if we go up from A to B? It's this minus this. We cover this distance. We are here, we are climbing up to point B. This is the altitude we went up by. From this, I subtract this. y2 minus y1. F of x plus h, perfect, minus, very good, divided by, awesome, x plus h minus x, indeed. Remember, f of x plus h, no one can touch. This is a fantastic expression. F of x, no one can do anything to. It's just a function. But look at the denominator and say, oh, you can simplify that a little bit. How? The positive x with the negative x go away. So this is f of x plus h minus f of x divided by h. This is what we call the difference quotient. Difference quotient. Difference quotient. Okay, you can say, yes, this was very interesting. But what does it mean? It gives the rate of change of the function between a and b. Rate of change between a and b. It's called the difference quotient. We will be asked to find it for any function. Let's create a function. After this, we're going to stop. Let's create a function. Give me any function you can think of. Let's start with the quadratic function. And determine the difference quotient will be given to you. You do not have to memorize this. My calculus class has to memorize it. My pre-calculus class doesn't have to. So this will be given to you. In calculus, they have to know it. Okay, so then give me a quadratic function, any quadratic function you can think of, and for which we would like to determine the difference quotient. Find it and simplify it. What I would like to do, because I don't want to hold you over, I like to come back to the function that we looked at the beginning of the class. So this is the function, and this is f of x plus h, because we already calculated it. So let me copy negative 3x squared plus 7x plus 10. This is what we are trying to find. And I'm going to copy f of x plus h, which you said then negative 3x squared minus 6xh minus 3h squared plus 7x plus 7h and plus 10. We're saving a little bit of time. Okay, so this is the function. We evaluated already f of x plus h. The difference quotient is f of x plus h minus f of x divided by h. I just copied it from what we came up with. Good. So now, let's analyze what we have and what we don't have. This is the function. I have it. It's this. Then, do I have f of x plus h? Yes. I already determined it. This is the f of x plus h. And no one can do anything to the little h. So I will put all these pieces together. I will copy, instead of this, I will copy all this. So negative 3x squared minus 6xh minus 3h squared plus 7x plus 7h and plus 10. Now I'm here. Here it is a minus. Remember the minus f of x? What do I have to do to find minus f of x to this? Exactly. Distribute to all three terms. Plus 3x squared minus 7x and minus 10 divided by h. What did we do? Really nothing. We just replaced stuff. We replaced this by what we just found out. We replaced this by the original function, but distributing negative 1 to all three terms. And now we only want to simplify this. Two things has to happen. Every time you find a difference quotient for any function on the planet, two things have to happen. At the top, all terms without h must go away. Maybe some of the terms with h will go away. That's a bonus. But everything without h must go away. But what is the second thing that has to happen? This little h must go away. that particular one. At the very end, I may still have h in the problem, which is fine. Okay, let's see. Negative 3x squared with positive 3x squared, gone. Positive 7x with negative 7x, gone. Positive 10 with negative 10, gone. How many terms are still left? 3 terms. They all have something in common. Specific. Exactly. Awesome. And this is how the h in the denominator goes away. Just give me the terms in parentheses. Awesome. Minus 3h. Perfect. Plus 7. And this is the simplified form of the difference quotient for this particular function. 2 things happened. All terms without h went away, and the remaining terms had all h in common that simplified with the denominator.